Welcome. My name is Krzysztof Szarkiewicz from Juniper Networks. I would like to present the joint testing performed by Telefonica, Juniper Networks and Keysight as part of the O-RAN PlugFest 2022 transport testing. So why O-RAN Fronthaul testing is important? Well, because we need to provide a good solution to the customers. And I would like to ask Luis from Telefonica as well to express his view on this.
Christoph, yeah, actually it's very relevant to understand the behavior of the equipment on the lab. Essentially, the idea is to have a clear overview of what could be the expected behavior once we move this into the field. And this is clearly interesting for operations, but not only for operations, also for planning, for engineering, the whole process of moving the equipment and implementing the solutions in the field.
Great. So Juniper has the full portfolio to address the 5G mobile transport needs, starting from the small ACX 7024, which can be used on the cell site router, so on the cell site locations, going through the ACX 7348, ACX 7509, up to ACX 7508, which is the big box that can be used in the aggregation side. And now let's discuss the test setup that we have used during the testing. So basically, we have small fronthaul network with two cell site routers, which are Juniper ACX routers, and one hub side router, which is as well Juniper ACX router. And to these two small network, we have RU, DU, and CU emulators, emulated by Keysight, connected on different locations. And of course, we have as well some background traffic to saturate the links, and as well Grandmaster emulated by Keysight. So let me give now the words to Avik from Keysight to explain more details about the testing.
Okay, thank you, Christoph. The O-RAN transport is very different from a traditional transport in the sense that it needs to carry time-sensitive radio data through the packet switch fronthaul. So validation of such a fronthaul transport requires creating realistic traffic pattern for the C, U, S, and M plane messages, the timing pattern, and all of these with large number of DUs, RUs emulation. So Keysight's RU-DU emulation capability based on IX network and Novus hardware allows the user to measure transport performance at high scale. It validates the KPIs that is required to carry the latency sensitive radio data, and therefore helps test compliance as per the O-RAN Alliance WG9 test specification. And in a system level test, the solution can be used to identify potential bottlenecks at specific transport elements. For example, the transceivers, switches, smart NICs, operating systems, or even the container engines. While validating the overall transport infrastructure at Keysight, we look at the 6 technology enablers. For us, the 6 pillars of 5G RAN transport are the time synchronization, the deterministic nature of traffic, the encapsulations that carry the radio data over Ethernet, or ECPRI in other words, the network slicing enabled by technologies like segment routing, etc., the virtual infrastructure that hosts the virtual RAN, and last but not the least, the security and encryption aspects. So our product portfolio spans across different stages of the life cycle, starting from pre-silicon validation at the left-hand side, which is covered by the product called IX Verify, then IX Network along with Novus hardware covering the infrastructure test, the conformance tests through IX Anvil, the network impairment tests through our brand new product called NE3, and finally, the virtual infrastructure validation through CloudPeak. Now, coming to the specific test configurations used for this PlugFest, each of the emulated ODU-ORU pair is configured with 100 MHz downlink carrier and 100 MHz uplink carrier with 30 kHz subcarrier spacing. This results to 1.75 Gbps of ECPRI traffic stream in both uplink and downlink direction. The traffic streams between OCU and ODU is configured with 1.2 gigabits of throughput in both directions, and also background traffic streams traversing the HSR or the hub site router, and each of the CSRs or the cell site routers is configured with 38.2 Gbps of throughput in both directions. The ECPRI streams are configured with proper COS settings for strict priority queuing so that they experience no loss and minimum network delay. With this configuration, traffic is blasted through the fronthaul to measure loss, latency, and packet delay variation. No packet loss was observed during the test as shown in the IX network statistics. Also, maximum latency for EC streams was observed as about 20 microseconds. Minimum was about 5 microseconds and average was about 6 microseconds. The IX network-based clock quality analysis tool was used to measure S-plane characteristics. Average time error on emulated ODU ports that was running a PTP follower clock was about 1 nanosecond. It means the HSR added only 1 nanosecond of constant time error while propagating time to the ODU. On the RU side, the average time error observed on each emulated ORU port was about 75 nanoseconds. Maximum relative time error turned out to be about 10 nanoseconds at ORU UNIs of those ORUs. So now I will hand it over to Luis once again to let us know about the importance of this validation.
So thanks, Avik. So we have seen along the presentation, there is a diverse and rich number of options in the deployment of front-haul, mid-haul, and backhaul solutions. So this shows the relevance of having a clear characterization of these solutions before going into the field. Not only from the operational point of view, but also the engineering, the planning. All of this is impacted, let's say, by a good characterization before going into the field. So I would like to thank Juniper and Keysight for this exercise. It was very insightful and relevant for us. And yeah, thanks for participating on this test.